and welcome to another OxyGEN tutorial. In this video, we'll show you how you can run and edit a simple protocol with our software. Automating an experiment has never been that easy. So after you have launched the program, you can either load one of the protocols you have previously created, or you can create a new one. We will start from scratch and proceed with a new protocol for the purposes of this video. The protocol editor workspace is organized in sections similarly to the live control view. As soon as you connect or simulate your devices, you will be able to see them here in the devices section, along with their properties and further connected valves or sensors. On the left part of the screen, you can see the library section, which displays all connected and simulated instruments in a tree structure. You will also see the related functional blocks offered to you to build a protocol. By clicking on the arrow next to each item, you can expand or collapse the drop-down menu with all the subsequent linked options. When you click on the option itself, you will see a list of functions and conditions appearing below the library panel. Note that this list is different depending on the device you select from the library. In other words, these functions only apply to the selected option. Tools, on the other hand, are available at any time and can be inserted into the protocol along with the functions. You can find the detailed description of all blocks in our user manual. Now let's take a look at the last main section. The protocol editor is your main working space for building up a protocol. It contains 4 working fields in which you will edit the steps of your protocol and follow its execution in real time. There is also a toolbar with operational buttons that we will go over in a moment. If you want to add a new block to your protocol, first select the needed device and one of the options in the library. Below, find the function you would like to set and either drag and drop it anywhere into the editor field or double-click on it to add it as the latest position of your protocol. The active block will appear instantly and you will be able to set the parameters. You can similarly add tools blocks to your protocol. We will talk in detail about how they allow creating complex protocols with loops and conditional paths in another video. As you add new blocks, you can organize them using the toolbar in the upper part of the protocol editor. Select the block and use the buttons to copy it, cut it, paste it, delete it from the protocol, move it to the left or to the right. You can also group several steps by selecting them simultaneously while holding the control button. Buttons such as step forward and step backward, create, open, or save new protocols are also to be found here. As you build up your protocol, it will be reflected in the Explorer field on the left of the panel. Now let's say we want to create an automation protocol for an experiment based on one reservoir with water to rinse, one reservoir with a specific liquid, one microfluidic chip, and a reservoir for collecting waste. For that, we need a link module, 2 flow easies, where one has a connected flow unit, and a switch easy with a connected 2 switch. With this setup, we want to automatically inject the sample liquid at a given flow rate for a specific duration. We want to automate the experiment in the following way. First, we pressurize the water reservoir with the first flow easy to prime the system. Second, we switch the valve position, set the flow rate on the flow unit, and let our specific fluid flow through the chip for 30 seconds. Third, we switch the valve back to water and rinse the system. Let's go back to OxyGEN and build this protocol. First, we connect our devices. Once it is done, they will appear in the Devices panel and the Library panel. At the start of the protocol, there is a block Reset All Pressures to 0, which is put there by default. You can delete it, but it can be useful to make sure your experiment starts in the newly defined conditions. Next, we set the parameters for the flow unit to adjust it for a specific liquid. For that, we select the flow unit and choose the block Set Parameters. Here you can define the limits, calibration table, response time, and custom factor. Also, we want the 2-switch valve to be actuated for the water from the first reservoir. For that, we go to the library, select 2-switch, and add a block Set Position. So all that we have done to this point is just configuring the system by setting the parameters. Then we need to set the value for the pressure from the flow easy, which is connected to the water reservoir. We select the first flow easy and add the block Set Value. We put the set point at, let's say, 230 millibar. If we want the water to be injected for 30 seconds, we need to add the wait block from the tools list. Let's have the user click to continue once the system is filled with water. To do so, we add the tool Wait for the user. You could type in a text of your choice in the text window that will appear when the protocol is running. Now we should switch the valve to proceed with a specific liquid. We do it with the use of the Set Position block, which we can just copy using the copy and paste buttons from the toolbar. We then set the value for the flow rate by selecting the flow unit, which is to be found under the flow easy it is connected to. Once selected, we do the same we did for the previous block. Select the Set Value function below. We want this flow rate to be maintained for 30 seconds, so we can just copy the previous wait block that we have just used for the water filling. For the third step of rinsing the system with water again, we insert the blocks we already used, switching the valve, setting pressure, and wait. So this is it. For the final step, you will want to reset all pressures in all the connected channels to 0 using the dedicated option from the tools list. By the way, when the protocol is running, you can always stop it and drop all pressures to 0 with the emergency stop button at the top of the window. Note that you can add comments to each block of a protocol in order to better organize it. You can now save your created protocol by using the toolbar. Run the protocol by clicking the play button in the top right corner. In the Runner tab, you can follow the steps, check on their progress, and interact with the system where needed. Here we can see that the system has been filled with water as we wanted, and the software requires users' interaction to continue. And here we can follow the real-time execution of this step. In the Overview tab, you can track how pressure, flow rate, and other processes are changing in real time. That's it for this time. Go ahead and try it yourself. OxyGEN will save you lots of time and make the automation of your experiments much easier. In the next video, we will dive into more advanced blocks such as loops and conditions. See you there.